All right, we've seen how to use the truth tables as a way of proving the validity of some schema. Let's look at some more examples. I'll just make up some valid ones here. Let's say someone gave us the following. They said P or Q, not Q, therefore P. We know that's valid right away because, look, it's intuitively valid. It's an example of what we'll call disjunctive syllogism. This has to be valid. So what do we mean by saying it has to be valid or it has to be a good piece of reasoning? We mean that there are no counterexamples. And as we've set things up, what we can do is we'll show that when it's set up as a conditional, it's a tautology. It's always going to be true. So let's go ahead and set this up as a conditional, not therefore P. Okay, so what are we doing? We're saying these two things are the premises. This is the, this is the conclusion. And so what are we saying? We're saying that if you have these two things, if you have this and you have this, therefore this, or you can conclude this. And this is what we're doing when we set it out as a schema. Okay, so let's go ahead and do it. Again, I know it's boring, but we've got to lay out our pattern of trues and falses. Eventually we'll be able to skip this and just go ahead and list TTTF for this because we know P or Q is TTTF. But for now, we'll just lay it out. We can do the negation here if we'd like. We know that this is going to come out TTTF. Just erasing them. You don't have to do this, but just so you can see what we're dealing with. So now it's TTTF, FTFT. We've got the AND here. We know that it's only true when they're both true, so it's false, true, false, false. It's probably best not for you to, or for you not to scratch out, because then you won't see if you make a, when you make a mistake, or if you make a mistake, you won't see where your error was. But you're going to have to. I'm trusting my 20 years of teaching logic to get through this challenging proof. Okay, so let's see. So now what have we got? We've got a conditional here, the horseshoe, implication rather. We've got the antecedent and the consequent. We know that horseshoe is only false in the second case. We know it's TFTT. The second case here is where the antecedent is true and the consequent is false. Do we have a situation where the antecedent is true and the consequent is false? Let's examine the first. FT, no, and that's true. TT, true. FF, true. And FF, true. So now what we've done is we have proven that this schema is always true. Valid. Good thing too. Let's do another one. Let's do another example. Let's use biconditional for fun, since it's relatively unfamiliar. So we've got P, if and only if Q. P biconditional Q. And then we've got, let's say, Q, and let's say we conclude from that P or P. Another pretty straightforward one, but let's lay it out again. So what have we got here? We've got P biconditional Q, P if and only if Q, and Q, therefore P or P. Okay, So let's lay out our truth table. Do we really have to? I hope we've all sort of figured out how the conventional truth table thingy gets laid out. But maybe one last time we'll do the whole thing, and then we'll quit doing that. So T T F F T F T F T F T F T T F F T T F F. Okay, so let's start with the most sort of least important operator. The most important, the MLO, is right here, as you know. Let's go over here and do this one. So P or P. P or P is true when P, TTFF. We can ignore all this stuff now. Now why? Because it's true if and only if one or the other is true. It's false when they're both false. And that's the last two cases were false here. So it's TTFF, which is P. That's good to know. All right, so let's work over here then. So the innermost would be the biconditional. We know that that is true, false, false, true. It's true only when they're both true. And now we've got the and here. So T and T is T, F and F is F, F and T is F, and T and F is F. You got it. Okay, so now we've got TFFF on one side of the antecedent, or one side of the conditional, the antecedent being TFFF, and then on the other side we've got TTFF. So we're looking for a case where the antecedent is true and the consequent is false, and that would disprove the conditional. We don't see that. We've got TT, T, F and T is T. F and F is T, and F and F is T. So it's always going to be true. Yay, valid. Okay, so that's valid. One more example. And then we're going to wrap this part of the course up. So let's, or at least I will. You'll still have to do your quizzes and everything. P then, let's say Q or P. And let's say not the case that. Not the case that. P then Q or P. Let's say not P. And let's say then we're concluding Q. Is that valid? Well, that one looks hard. Is it valid? What do you think? So check your intuition, look at the layout of the sentence, and then we'll test it. So let's go ahead and test it. So we've got, I'll try to be neater than I usually am, P, then Q, or P, and not P, then Q. Let's run this truth table. T, T, F, F, T, F, T, F, T, T, F, F, T, T, F, F, T, F, T, F. Okay, so the negation of P would be F, F, T, T. And let's do the inside stuff here. So we look at the innermost. The parentheses show us what the innermost is over here. We should have started there, I guess. Q or P. Q or P, we should know it's TTTF, but let's go ahead and do it. T and T, it's true. F and T is true. T and F is true. And F and F is false. there we see what we're dealing with. Now we've got P, so is it the case that if P then P or Q? Well, should be. So T and T, true. T and T, true. F and T, true. And F, true. So the inside part is a tautology, but look, we still have to negate it out here. So the negation of a tautology is always false. Okay, so we've got always false for the value of this stuff over here. Whoops, I probably shouldn't use the same color. And then we've got and not P. So join always false with and not P. Well, we know with an and, if it's always false, then on one side, then it's going to come out false. So false and false is false. False and false is false. False and true is false. False and true is false. So now we've got this, false, 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 as the value of all the stuff on the inside. Okay, so we've got false, 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 horseshoe, Q. And we know that the only time a horseshoe gives us a false is if the antecedent is true and the consequent is false. That's not the case here because the antecedent's always false. So what do we got? We've got true, 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 true. Voila. Valid. Okay, thanks guys.